My name is Emma Boyce. This is the video demonstration of the catapult that I have made using a mousetrap for my assignment 1, Forces in Motion in Context, for ESC 101 with Charles Darwin University. As you can see here, I have constructed a catapult from using a mousetrap. To construct it, the bait piece was removed from the trap safely using a pair of pliers because it's not required. Then using the buffer foams are attached to the mousetrap, as these are going to act as a force to suddenly stop the lever when it's released. Then I have used the crossway segment here. It's made of 2 plastic spoons. I also have the spoons in various lengths, so a full length spoon as well as a medium length spoon which has been cut to size, and a short length spoon as well. As one of the main components of my experiment I've chosen to do is what the effect on the length of the lever has on the launch of the marshmallow. I've chosen to use marshmallows solely as A, they're affordable, B, they're safe and shouldn't prove to be a hazard in terms of flicking them, even if they were to bump a student or hit a student. They're soft, they're not going to hurt anyone. And also because they're relatively light and therefore should actually have quite a good trajectory from the device. So as a demonstration now, I'm just going to stop the video for a minute so that I can actually set up and launch a marshmallow with the device. I have the device here and I have it loaded with a marshmallow. Now it is quite difficult to do with one hand to demonstrate on the video, but I'll give it my best attempt. So it's easier in terms of learners if one learner holds the bottom of the mousetrap onto the flat surface, preferably perhaps like a gymnasium or a quadrangle outdoors if it's safe and if it's good weather, not inclement weather. And so the catapult can then be released and hopefully we should see a fine arc as the marshmallow is launched from the catapult. I don't know if you could see that just then, but it actually got quite a high trajectory and it hit the ceiling fan at the top of the room. I'll demonstrate again with another marshmallow. Just releasing it. I'll actually highlight the room this time instead as it's released. That one instead came back. It flipped behind the unit rather than in front of. As I stated before, the variable of this experiment is the length of the lever. So I would be asking learners to consider whether the length of the lever would have an impact on the trajectory of the marshmallow being launched in the catapult. So just to demonstrate that I have done it at different lengths as well, I've attached the smallest of the spoons, the shortest of the spoons, and I'll launch that now. I'm not sure if you could quite catch that there, but that one did have a nice arc to it and quite accurate trajectory. So it's one thing that lab learners could hypothesize whether the marshmallow will go further in distance, but also whether there would be more accuracy with shorter or longer levers. I'll just do one more. So okay, that one launched quite nicely. So that's the basis of this experiment in terms of how it's conducted, and you can refer to my assignment information for the discussion on aspects pertaining to the length of levers, distance, accuracy, and what would actually be tested in terms of hypotheses for the letters. Thank you.